Thank you, everybody, for joining us. Greatly appreciate it. Jorge and I have been working with Eagle together maybe for approximately 30 years, so we have a lot of experience. And this webinar series that we do, part one and part two, getting started, is to get you a good introduction to Eagle and how to work on your first project. On Tuesday, we worked on the schematic. We discovered the different methods that are available to search for components on the schematic, how to place them on the schematic itself, and define its connections. And we're going to be covering from the schematic over to the board. So as I stated last week or last Tuesday, Eagle is actually a platform that consists of multiple editors. So the main ones are the schematic editor, the board layout, and the library editor. And each one of these are discussed individually throughout the month. So on Tuesday, we discussed about the schematic editor, which was part one. Part two, we're going to be talking about the board layout editor today. And later in the month, we will be talking a little bit more about the libraries. Now, the first screen when you actually load Eagle and start it up, it's always going to come to the control panel. Control panel gives you an overview of all the aspects and all the different editors that Eagle contains, as well as the assets that are available for each one of those editors. Now, from the control panel, we moved on to the schematic editor, in which we actually created a brand new schematic, define our workspace in the form of a frame. We place the components and define our connections. We actually did run ERC to make sure that there's always no. It's not a simulation tool, but it lets you know that if you connect it to ground, to a different supply line that is of a different name, it'll actually let you know because of its supply connection. Okay, and from there we'll go ahead today and we'll create our circuit board. On the circuit board today, we're going to be actually moving those components within the board, defining a layer stack up, which actually is how many layers is my board going to have. I'm going to be moving those parts into the outline. Maybe we go ahead and we're going to modify that outline or import an outline from Fusion 360. Move those components, rotate them, mirror them. That way they're in the top or on the bottom side of the board. Now, one aspect that we have, which is really nice, is that when you're working in Eagle on a schematic and a board, Eagle keeps consistency, meaning that any modifications that are actually performed on the schematic will update the board layout. So if I delete portions of the schematic or I add elements to the schematic, those components will be added, or those assets will be added to the circuit board as well in real time. If you have a two-screen setup, actually is very useful because as you work on one, it will highlight the aspects on the other one. So actually works really well, and it's in real time. Now, the last portion of our webinar today is going to discuss how to generate the data to get your board either prototype or manufactured. This is also referred as the CAM processor, in which we're going to be generating the Gerber files and the appropriate Excel files. So I'm going to go ahead and stop sharing my screen. That way Jorge can set up his screen.
Okay, can everyone see my screen?
I do. I turned off my microphone. I muted it.
Okay, cool.
Yeah, I see your screen is fine, George.
You see the benefits of one monitor?
I see the benefits of multiple monitors all the time.
All right. So this is where we left.
George is an advocate for single monitor workflow.
Yeah, little silly controversies we do to keep ourselves entertained. So right now, this is where we left off on Tuesday. This is the completed schematic that we did last time. We showed you how you can tab the selection filter, inspector, and even the sheets. So that can help you to get back very precious real estate as you work on your design, and we'll see that be really helpful now when we switch to the board. So currently we don't have a board for this design, so all we have to do is we click here on generate / switch schematic to board. You'll see that you get this warning. Basically Eagle's telling you that a board doesn't exist. Do you want to create one based on the schematic? We're going to say yes, and now here we have the board. Okay, and you'll notice that I have a similar workflow here. I've tabbed the design manager, the inspector, and the selection filter here. And on the board, the selection filter can also filter based on layer. Okay, so it's really useful, gives you very, very precise formation of groups. By default, everything is included in your groups, so that makes it really easy to get used to because basically it works just as it always has. And then if you have to do more particular selections, then you can just disable whatever types of items you don't want to select, you know, and you can drag, you can do control, left click to pick specific ones, and then reset to bring everything back to normal. So with that said, let's go ahead and get started here. So you'll notice that we get a default board outline. If you have the standard or the free version, it's going to be the size of your limits. So this is going to be an example of the size limitation. Remember that Eagle's size limitations now are based on area. So as long as the X and the Y dimensions of the board multiplied, the product of those two, gives you less than 160 centimeters squared for the standard or 80 centimeters squared for the free, you'll be good. So right now I have the premium. In the premium, it just gives you an example size, which is the standard size. That's what it does for the premium. You'll notice that all of our components are here on the left side of the origin. The origin's right here, here's 0, 0. Okay. And this is how Eagle will always insert components as you add them to the schematic, because forward and backward annotation is maintained. They'll be appearing in the negative x-axis. Now, if you have a size limited version, this is the only time they're allowed in the negative x-axis, because the way Eagle defines the board size limit is basically 0, 0 being the bottom left corner or the bottom left edge of your board, and then it goes to the right and up from there. Okay, so keep that in mind, especially if you have a lot of components. If you're in a size limited version, it's usually not a good idea to bring everything in one go. You know, bring them in as you need them, arrange them, because if you bring everything in one go, you won't be able to take them out to make room to try to arrange things. So that's just a word to the wise if you have a size limited version. So let's go ahead and get started with making it. One thing you're going to notice is there's a color difference between the inside of the board and the outside of the board. What this lets you know is that Eagle recognizes the board outline as a closed contour, perfectly closed. This also is part of what drives the ECAD-MCAD integration. So it is important that you make sure that your board outline is a perfectly closed contour, that it doesn't run back over itself, things like that. And you'll know because the colors will change like we see here. So let's go ahead and bring in our components. Now in this case, because this is a very small design, I can bring everything in one go. It's not really a big deal. The highlighting, if you notice the highlighting looks different than maybe what you're seeing in the default version of Eagle, that's because I have high contrast mode on. And you can access that by going Option Set. And you'll see that I have high contrast set over here. This is a new feature, a new option that came in by request that allows users to control whether unfinished routes appear transparent or if they just look highlighted like in older versions of Eagle. So keep that in mind for those of you who prefer to have a non-transparent work in progress trace. You can adjust that here. So now what we'll do is I'll go ahead and actually shrink the board around this, because obviously we don't need all this board. I'm just dragging it down. I left click and I'm dragging. You'll see it all comes down together. I'm pretty happy with it there. Now again, just left clicking and drag. Obviously I'm freehanding. There are ways to do this more accurately. You know, you can type in specific locations and points, but for our purposes, this is good enough. So one thing that's really interesting is that when you're doing layout, you do want to think about the physics of layout. So a couple of rules of thumb that are good to keep in mind. You want to keep traces as short as possible. Things that are functionally related generally want to be together, you know. So if you have an inverting op amp, you'll generally want to have the op amp, any feedback resistors, the bypass cap. You want to have all that kind of grouped together. And then those groups, you interconnect them. That's a pretty good workflow. In a circuit like this, which is just a little blinker, I could pretty much route it any which way and it would work. Nothing, you know, this would be fully functional. There's nothing that could be really done to mess this up from a signal integrity point of view. So it's very forgiving. It's a very forgiving circuit. And most of Arduino type circuits, things like that, tend to be pretty forgiving as well. But it's something to keep in mind. You know, if you're going to do high speed, if you're going to do RF, those things require a lot more care when doing the layout, because then the laws of physics really come to bear, and if you don't take them into account, you can end up with a functional board just because the trace wasn't the right length, didn't match the right impedance, things like that. So what we're going to do, even though we know we could just kind of let it rip for the Autorouter, let's try to kind of arrange things, get them a little bit cleaner, a little bit more organized. So I know this one over here, this is a bypass cap. So this should probably be around here somewhere. I'm not too concerned with the fact that I have overlapping text right now. I will be addressing that shortly. I know this goes over here. Okay, this one is on pin 5. It's going to be somewhere like there. This one goes to pin 3. Something like that. Now, one thing that you want to notice is you'll notice how the air wires stay attached. That's what these little thin yellow wires are. If you hit the rat's nest command, they'll recalculate for shortest distance. So you may see certain things clean up right now. So I'll left click here, and you'll see that the trace has changed. I'm going to go ahead and undo it. Keep a close eye, keep a good eye on this, rat's nest. You'll see that it changed. Okay, we'll see that actually we have this one kind of reversed. So that's easy. We can go to inspector. We have our options here. So I'm going to click on this one. Just going to rotate there. Okay, inspector is extremely handy. It allows you to adjust the properties of a component as well as the common properties of a group of components or group of objects, really is more accurate to say, because it can be wires, it can be anything. So we got that there. Okay. That goes there. I'm going to go ahead and put this one over here.
Not sure if you wanted to show them, the alignment features that they could use using the inspector and grouping them and maybe rotating along itself, maybe.
We could do that. So let's show off a couple of things there. So one thing that's really handy with inspector that wasn't possible before, you're going to notice right now, because I have my selection filter completely wide open, everything is coming in. Okay. So if I switch to devices, you'll see that I have other options coming in now as well. Now what we want to do is, since we're going to be messing with these only, I'm just going to switch it to devices. Form the group again. Whoops. So I get for double click and go to inspector. And you'll see we have options. One thing that wasn't possible before was to do these types of rotations kind of in place, Well, what ended up happening before is that the entire group would kind of rotate about an axis. So, well, you're muted right now.
Yeah, so like R3 would be your center sort of when you would do rotation in the past.
So let's actually highlight that using the rotate command here. Set to 90-degree increments. If I control right click to apply the operation to the group immediately, you'll see that it all moves like that. But they don't really rotate in place like they can now with the inspector. So that's new. That's a new functionality for those of you who need that. There you go. Brand new functionality with the rotate command. Okay. You'll notice that again, we have common properties. They all have the same Y position. So through here, I could move them all up, move them all down. You'll see, I just press enter. I can bring them lower. Change angles, mirrors. All of these options can be controlled. Now, another thing we want to keep in mind here is the use of the align tools. And they're available in the inspector as well, but let's go ahead and play with them a little bit. Just going to move this up a little bit. Okay, there we go. So let's talk about these tools. Okay, they're accessible either through the align command here or through the quick actions over here in the inspector. So what does a line do? The idea of a line is to kind of be able to put components in nice little rows or columns. So there's a few options you're going to see available with it. So right here we have a line left. So what it's going to do is going to look at the boundary formed by the entire group. And in this case, it's going to align everything to the leftmost edge. So if I left click here, you'll see that everything is aligned to this left edge. Okay, likewise, right, everything aligns to the rightmost edge. Here we have top. You guys get the idea. Now, one thing that's important to note is that the order of operations is very critical here. You know, if, for example, I want everything to kind of center, you know, towards the middle or a certain position, then what I would want to do is I would do something like this. Now they're all at the same position, and then adjust them to make them go up and down. Certain combinations of operations, if you don't do them right, will end up with everything kind of smushing together. So for example, if I do a left and then I do a bottom, everything runs over each other. So keep that in mind when playing with these parameters of the align command. Now, one thing that's nice is so you want them evenly spaced horizontally, because currently they're not. You know, you'll see that there's not an even spacing between them. Then you can use this option to kind of distribute them better. So you click there, you'll see our three moved. I align them to the top, evenly spaced. So it makes organizing the position of groups of components really, really easy and straightforward. So something we encourage you to check out. Like I mentioned, it's available here in the inspector, and it's its own icon over here. Okay, so I am going to grab this now. I'm going to rotate it. There we go. I'm going to go ahead and do this, rat's nest. There we go. You see how it cleans up? It's looking better. Grab this one. Put them like right there. It's fine by me. There we are. Just bring them a little closer.
I was thinking maybe on a future design we bring in an on-off switch.
Yeah, we can do that. Just going to tighten it up a little bit. Probably tighten it up a bit more, but then I'd be getting a little bit OCD on that, so there's no need for that right now. Just gonna lower. Oh wait, I got my selection. Ah, knew it. Reset. Selection filter is very handy, but it takes a little getting used to. Okay. Now, one thing that we want to note here is the fact that the font is proportional, and on the board, proportional font doesn't make it to the Gerbers. It actually all gets converted to vector font. So depending on the use case, some users like to leave it in proportional and let Eagle handle the conversion. Others want to explicitly see what the finished board is going to look like, so they change the font. And there's now a whole bunch of ways to do that. And one way is to pick attributes here and text. So control, attributes. I form the group. Now we go to the inspector. You'll see that all we have is text here. And I can go to font. I can say vector for everything, and there we are. Selection filter, back to normal. Okay, so it's really helpful.
Yeah, that LM555 definitely changed.
Yeah, you can tell it's a different font completely. So I'll go ahead and put this one. Put it right here. It's fine. Bring this down a little bit. Use the Alt key just to kind of. The alternate grid gives you the Alt key. is given by the Alt key. So if you hold, if right now I'm just moving it normal, you'll see that it's moving based on the grid spacing. If I hold Alt, I can use the alternative grid, which is a little bit finer. Okay, there we go. Now, one thing we normally don't need on a board are the values, so I'm going to go ahead and turn that off. So I go here to layer settings. There we go. B values, T values. Say OK. There we are. Okay, so at this point, there's a couple of things we can do. We could go ahead and start routing. We could add in a copper pour. So what I'm going to do is I'm going to do a copper pour. So this is a polygon command. This is the one you use to draw the polygon. Again, key with polygon, same as the outline. Needs to be a perfectly closed contour. Okay, you give it a name. We're going to call it ground. And then if I rat's nest, you'll see that it fills in. Okay, perfectly filled in. Anything that's connected to ground gets thermal connections. Okay, these help build up heat so that you get a good solder joint. So it's definitely always a good idea to have thermals on. Okay, if we want to unfill it, you just click on the rip up command, all visible polygons, and you'll see it'll go back to this way. The rat's nest command pulls double duty here. So it lets you both fill the polygons as well as recalculate the air wires. Okay. So now what we can do is we can go ahead and start making connections. Now, before we do that, I want to show you one alternative to just drawing it freehand with the polygon command. If I right click on the outline, there's a convert to polygon. You pick copy to make a polygon and leave the original outline alone, or replace to swap them out. So if I pick copy, you pick the layer, and then it'll convert it. Really, really useful, saves a lot of time. So let's go ahead and start routing. Now I'm going to preface this by saying that we are not doing an in-depth routing tutorial, okay? We dedicate an entire webinar to routing usually, to all the different modes and everything that's available. But let's make sure you get a good idea of how it works. So you'll notice it's in walk around mode. Walk around and push are the two assisted routing modes, where basically Eagle helps you get the routing done. So for example, walk around, you'll see that it will avoid connecting to anything that's not part of its net. It's going to walk around it. Okay. And then push, if there's any traces in the way, keyword traces, it will move them around. It will kind of push them out of the way. So what we can do here is we're going to go over there. So I left click to start it, left click to end it. What's the snap to center? Now notice what can happen here. If I want it to bend the other way, I just right click. Really handy. Okay, and you just proceed to do that for as many traces as you need. Now let's say you're routing and you end up doing an ugly trace like this, and you're like, I want to go back. If you just press backspace, you'll undo segment by segment. Okay. So right here, I have a clearance thing going on because my grid is very coarse. So what I can do here is I can hold Alt. And you'll see it'll walk right up to it. It's going to maintain whatever the clearance defined in the DRC is. Okay, you can just proceed like that. Now, if we need to transition from one layer to another, what you can do is you can left click. If you press spacebar, let me actually make it visible to you guys. Look at the bottom of my screen down here. Come on. See where it says next layer bottom? If I keep hitting spacebar, it'll cycle through all the active layers, all of the active copper layers. So this is a 2-layer board design, so it's going to go back to top. Okay, so we're back to top. Spacing brings us down. Now we're on the bottom because you can tell because it went blue. So now you'll notice that because I'm on the bottom, it's just going to give me some, it's going to let me connect back to the top over here. But what I want to show is what happens if I have a push active. Oh, it's going to let me go through it because it's acceptable. Actually, yeah, it's the same net. That wasn't going to work. We'll go ahead and finish this one off.
Use 5 volts from R2 maybe.
Yeah, I'll use something else. It's really, this is a very trivial connection that I'm making complicated. So what we'll do is I'll just go from here to here, and then we'll go ahead and rip this part up. So good time to show rip up. So rip up has several options. The default one is the old one, where basically we just go item by item and rip it up. But now there's a few smart modes. For example, you can say all connected copper. So if I click just on the end of the via here, it'll rip up the whole thing because it's all connected copper all the way back to the pad. So it can save you a lot of time. So now let's go ahead and go over here. I still have the, oh no, still don't rip up now. Click there. Okay. I can right click. There we go. Switch to the other bend style. So far we've routed everything pretty much manually so far. And that's just because the circuit has been laid out in such a way as to make that easy. Now, let's try an example here. I'm going to go ahead and save this. What happens if we run the Autorouter? Okay, everybody loves the Autorouter, especially if you're new to PCB, because like it'll do all the traces for you. Keep in mind that it's not aware of physics. Okay, it really is trying to get everything routed. So if you have critical traces, you can't leverage it. However, the way the Autorouter is set up is that it will respect any existing traces. So right now we've laid these traces out. The Autorouter is not going to touch them. It's going to do whatever it can to get everything else routed. Okay, and we can see that by just running it. So I'm going to click Autorouter. I'm going to put the effort to low. Okay, auto grid select is okay, variant top router. I have, I think, a 4-core or an 8-core machine, 4-core. So it gives you 2 threads per core. You'll see that I only have a top and bottom, and I've set it to auto so that the Autorouter can do different variations. So I continue, and I get 5 variations for this design. So I'll press start. You're going to see that it's completed. Everything went to the end. Now, one thing to note about this is that the top router algorithm is computationally much more intense than the old or the normal Autorouter algorithm. So it can take a considerable amount of time to run. Whereas you'll notice probably these all finish quickly. This one can take a little while. So if you're ever wondering if Eagle is hung or something, just go to one of the other ones that's still running and you'll see that Eagle is working on them. Generally, you're going to want to wait until they're all, you know, they all say done. And if they weren't able to make it to 100%, then they'll tell you how far they got. So at this point, if you notice, all the traces we did are untouched. The only stuff that's new is what's showing up as I click the various variants. Okay. Key rule with the Autorouter, very, very important. Okay. If you have a huge board, you can pick one and you can click evaluate and start looking around, seeing how it looks, if you're happy with that result. Okay. And that's all right. But at some point, you always have to end the Autorouter. So right now I'm in evaluation mode, and I can make changes, I can make adjustments, and Eagle will try to sync them. But if I keep working and making too many changes, at some point it becomes too much for Eagle to keep track of, and you can run into issues. So the key rule with the Autorouter is make sure to end it at some point. And the way you do that is we go over here, you'll see there's an Autorouter icon over here. It'll actually say Autorouter job pending. We click it, it says data is available. I'll say evaluate, and I can get back to the others. Okay, and let's say I just want to keep, I don't know, say I want to keep this one. This one looks good to me. Say end job. As I zoom in, it'll refresh the drawing, okay? You can see everything is now routed. If I run the DRC to check, no errors. If I did rat's nest, it'll say nothing to do at the bottom if there's no more air wires. The DRC will catch any air wires that may be remaining, so that part's okay. And this is basically the board. Okay, we finished routing our board. There's lots of options, like I said, to the Autorouter. There's lots of things you can do. So like right here, for example, we have this L. If we right click on the route command, there's this smooth signal command. From quick route, you just left click on a trace and it'll clean it up. It'll straighten it out. So if I rat's nest and recalculate the air wire, you'll see that it cleans up nicely and it's a little bit straighter. And I can do the same thing over here with this one. Again, rat's nest, everything moves. So leverage that. It's very useful tools. Makes it very easy to get all your routing done in a nice, clean way. So at this point, I'm going to go ahead and save. And I'm going to show you the easiest way to get manufacturing files out of Eagle. Okay, we have two main mechanisms. One is the CAM processor. The other one is the one-click CAM, or the generate CAM data option. Basically, they run from the same, they're the same thing. The difference with the generate CAM data button is that it analyzes your board stack up and picks an appropriate template. So this is a simple two-layer board. It doesn't have slots. If it had slots, I wouldn't be able to use this option. But because it doesn't have slots, I can. So all I do is I left click on it. It tells you that it's going to use template two-layer CAM. It says it will create a zip archive containing the following files. Okay, you see everything it's going to make. It's going to make top, bottom, outline, which is a profile, solder mask top, bottom, solder paste top and bottom, silk screen top and bottom. So I'm happy with this. I'm good with these files. I'll say okay. And it's going to ask you where I want to save them. By default, it's going to point to the directory where the board and schematic are saved. So I'll save it. And there we are. And there's our manufacturing data. It's that simple. Now, one thing you always want to do before you send off a board to manufacturer is to double check the Gerbers, okay? It is important to do so because in the end, the responsibility lies with the designer to make sure their manufacturing data is correct. So if you send them bad data and the board house processes it and gives you bad boards, you may be upset that they didn't tell you anything, but the responsibility ultimately lies with the designer to provide proper manufacturing data. Good board houses do inspect the Gerbers that come their way, and if they notice anything unusual, they will usually inform you. They'll reach out. But if you're going super cheap, don't assume it. You may not get that call that, hey, you made this mistake, and what you'll end up with is a bunch of boards that don't work. So what we're going to do now is we're just going to go ahead and inspect them, and that will basically conclude the webinar. So I'm going to go to my Gerber Viewer of choice, which is ViewMate. There's plenty online. If you're into free and open source software, you can use GerbV. There's GC Preview. There's online. There's Circuit People. Depending on the board house, they'll have a built-in kind of Gerber Viewer, and you can use that. But always verify. Always check them out. So what I'm going to do now is I'm going to go File, Import. I'll pick Zip. I'll go to that location. Getting started. Here we are. Double click it. You notice that it'll pull away anything that is not a Gerber. The other thing you'll notice is that these files have formats, okay? Right now, these are the default formats that ship with Eagle. They're metric 3.4 and the draw files 3.3. All of these format information here is not carried in the Gerber itself, okay? The Gerber Viewer makes an educated guess at the formatting. It's not always right, okay? As you can see here, green indicates that a format was calculated from a blue. Blue indicates that it wasn't included. That can happen sometimes where you get a bad guess. You just have to go and adjust the format. I don't have to do it in this case because they all came in correctly. You can go here and edit the format. So now I'll say OK. And we can see everything looks as expected. We have our board outline. We have our pads. Okay, if you want to turn off a layer and see something specifically, you can see the drills. You can see top copper, bottom copper, top copper, board outline, etc. You can just verify that everything looks as you expect it to, you know. So that's everything we wanted to cover today.